Hi everybody, my name's Finley. I'm an aerospace engineer and I'm part of Safe Landing, which is a global community of aviation workers and enthusiasts who care about the future of the planet and also of our industry. This is a Airside chat series where we talk to visionary thinkers and innovators in sustainable aviation. So really happy to have Josef Mouris here with us today. Hey Joseph, how you doing?
Hi, it's entirely my pleasure, Finley.
Thanks for being here. So Joseph actually been in Safe Landing for a while. I think back in 2020, you maybe joined the group. So it's great to have you here and kind of hear a bit more about your journey since then. But yeah, it'd be great. I'll let you introduce yourself, hear a bit about how did you get into aviation, into flying, and then into sustainability.
Yeah, sure. If it's all right with you, I'll share a couple of slides, pictures as we go through. Find it less, boring to,
Yeah, go for
to
it.
look at, and it gives a little bit of texture to what I'm saying, perhaps. Let me see if the screen is working for you now.
That's good.
So you'll see there, that's my mum, actually. She's a glider pilot, and that's me strapped in front of her. She actually was flying gliders until she was 6 months pregnant. So I was infected by the flying virus back then. And that's my dad sitting in the back, but I think that's the one and only time he's ever been in a glider. He was more into cars. Flying's not his thing. But that's kind of how things started for me. And then from there, when I was 9 years old, I actually saw also what was then called F3E, and now it's called F5B, which was an electric model airplane competition, World Championships happening in the Netherlands that year. And it really excited me back then, like the carnage and seeing these planes like take off vertically and stuff. It was just kind of insane what's actually possible with batteries back then already. Um, But unsurprisingly, to my parents and my friends, I did went and study industrial product design for a while, thinking maybe of a career in aerospace, but nothing much seemed to be going on at the time. No real innovation, and really nothing much in terms of sustainability. Not that that was even on my agenda back then either. Um, but I wanted to become a pilot, and so that's what I did and achieved that at age 21. I did most of my training here in the UK. I'm originally from the Netherlands and got a job straight away, and then spent the next 15 years flying for Europe's largest regional airline, flying the short kind of distances from Southampton, which was my base. I was in Glasgow before that, to Amsterdam, to Manchester, to Belfast, to Paris, those kind of short trips. And then came, of course, 2020, um, when everybody was sitting at home with COVID, and my world kind of like changed, turned upside down a bit, if you will. Um, so yeah, a bit of reflecting at that time.
Yeah, I think that's true for actually quite a lot of people in safe landing. There's a quite a change in the political temperature around climate towards the end of the 2010s, and then COVID happened and kind of put into perspective some of the external impacts that can hit the sector, whether that's a health pandemic or a climate emergency. So my understanding is you at that time you're thinking a lot about the future of the industry and sustainability,
Mhm.
and decided to actually launch your own startup. So just before kind of getting into some of the specifics of what your company does now, like
Yeah.
why did you choose to, I suppose, start your own thing rather than look at maybe what some of the big manufacturers or other startups were doing and get involved there?
Yeah, it's quite a big ballsy move, right? Pretty crazy. So, as you rightly say, I was also looking at this outlook, and I became more aware of, okay, maybe it's like 2.5% or 3.5% today, the emissions of aviation, but by 2050, it could be 20% or more, the rate that the direction that the industry is going versus everything else. And I've got two young kids. They're a bit older now than here in the picture. But that didn't sit right with me. And I was looking at what needs to happen between now and 2050 when everything is supposed to be zero emissions or net zero or sustainable, and didn't see that change coming from the incumbents. So for me, my mission kind of changed to say, actually, I want to be part of securing the future of aviation for the next generation because I love, flying. I think it's a great thing. So I started looking at all the alternatives, and the most talked about one probably is SAF, sustainable aviation fuels, which others I'm sure will talk about in great detail. But I realized quite quickly that there's been a lot of targets set and there's mandates and things, but it's actually practically impossible. It's very hard to scale that. And you can argue about whether or not you're actually improving the overall situation because you're still burning it, you're still producing emissions. So you can argue that it's a loop, you absorb it by plant matters and whatever, and then you use that to make SAF fuel again. But it's not so green or so simple as it might seem. Um, and then the next one is hydrogen, which other companies, and I don't want to be too negative, are working in that space. But again, I realized today we have a massive hydrogen industry and a massive need for hydrogen, and 99% of it is from fossil fuels through a process called methane reforming. So there is a need for green hydrogen, but there's also plenty demand for that green hydrogen already. Um, and so in aviation, not only do you need then completely, it's entirely new airplanes to be able to use it, you need all the infrastructure, and then you're not going to be able to get it cheaply because there's going to be this massive demand already for it from the existing industry. And if we then look at automotive, we already know, what's happened there, how that turned out. They had all those kind of alternatives there as well. And if I'm looking at the efforts that were happening in terms of electrification in aviation, it was mostly just eVTOLs at the time. There was a company called Aviation in the States building a nine-seater electric plane, which kind of seemed to go in a sensible direction. Maybe not the initial designs with like motors on the wingtips and stuff. But other than that, nothing much was happening. And of course, you're not going to be able to fly halfway around the world in an electric plane anytime soon, if ever. Um, that wasn't really, that's not going to be the solution for that. But we'll come back to maybe the bigger picture a bit later.
Sure, yeah. So yeah, so that's kind of you saw issues with, and I think at Safe Landing we recognize those issues as well in terms of timescales, uh, sustainability and scalability of some of those options. Um, and even if they are going to be an option, we've got like multiple decades until we've got them at scale. So we need to do something in the meantime. And yeah, as well, most electric aircraft that we've seen, you mentioned eVTOL, the vertical takeoff and landing aircraft that have got a lot of focus and funding over the past 10 years, but not so much for just kind of conventional aircraft that are powered electrically. So yeah, really interested in where you've gone to there. So could you tell us a bit more about Electron? I understand that there's sort of the aerospace company and the aviation section of it. Like, what is your plan with that, your mission and your vision?
Yeah. Um, so we looked at it, I talked with friends about it and kind of tried to dissect the whole thing and understand how this is all going to play out over the long term, and then working backwards from that to where we are now. Um, and again, automotive, we've seen this all play out once before. Tesla did not start with a mass-produced, low-price electric car. They started with the Roadster, which was a sports car, which was an originally Lotus Elise converted to electric. And already today we have now the Pipistrel, which is a two-seater battery electric plane flying. It's kind of that first step. It's a retrofit airplane like the Roadster was. And from there we need to kind of like build better and bigger electric planes. And eventually, we can potentially do all the short haul battery electric. But it's not going to happen overnight. And building a plane of that size also costs huge amounts of money. We need to start with smaller planes. And then when we started thinking about those little planes, what they could be used for, we got really excited about the idea of operating those planes. So we were looking for more of those planes. We actually wanted to start an operator and buy some of these small planes, and start these regional operations, these regional flights, the type of flights that I used to do with the 80-seaters, the 118-seaters that I used to fly. But that didn't really exist. So we ended up deciding that, okay, we'll build them ourselves then. Um, and what's really interesting about that is once you actually have these small electric planes, they're so much cheaper to operate than private planes today. And private aviation is like has this really like for us in aviation like or normal people, it's like very expensive, elitist, bad for the environment. It's like all the things we don't like. And the irony is that if we make those planes electric, that kind of thing gets turned completely on its head. So the question I kind of asked myself, and you can ask it to AI as well if you like, is what happens if you take this fastest mode of transport, which is private flying, and you make it 90% cheaper and you make it also the greenest mode of transport? And I really mean that, the greenest mode of transport. We'll come back to that. Then what can happen is you can actually see something we've seen in the past before, which is, we had horses, then we had cars, then we had the train, and airplanes have come in and taken over a lot of the market share. It's still massively growing all around the world, aviation. More recently, we've seen like Uber come in to make ride-hailing much more popular, and therefore taxis much more popular. So having shared mobility instead of everybody having your own car, which is a step in the right direction. But what if flying actually became as easy as booking an Uber? Um, that's what we started thinking about with these small planes. So today there's maybe 30,000 or so commercial planes out there, maybe 30,000 private planes, compared to 1.5 or 2 billion cars that are parked up 90% most of the time as well. It's really interesting kind of perspective to look at. And if you look at what that could mean is actually a massive move from the road to into the sky. So there's a real strong positive opportunity here for aviation and aerospace to expand in a way that actually is sustainable. We can have some actual sustainable green growth. And companies like McKinsey realized that this is likely to happen. So there is a report that they wrote in 2023, I believe, which breaks this down a bit, and they put some numbers to it, which is good to see. But that gives you a bit of an idea of the way we look at it and what we're working on.
Nice. And I think part of that is so when you try to think about being an operator, um, buying electric aircraft to operate that kind of um, ride-hailing experience, but with electric aircraft. I guess you're sort of finding that there wasn't much out there that you could actually buy. The Pipistrel you mentioned is this trainer aircraft with two seats, so you've got the pilot and one other. You can fly for sort of less than an hour. So at that point, you also like we actually maybe need to consider designing and building our own thing as well.
Yeah, so if you look at the mission profile basically of what the service or the aircraft needs to do, like we see in the car, typically it's around two people in a car, and also in private aviation is around two people in the vehicle. And half of all private flights in Europe are less than 500 kilometers. So if you look at this kind of journey profile of, say, 500 kilometers for two people, you don't need to go to an airport and be there an hour before, and the airport's probably also 15 minutes away from you instead of an hour away driving. Um, then actually your travel time is much shorter with an electric plane. The cost is comparable to train and commercial aviation, and the emissions is actually less because we use far less infrastructure and we use the vehicle much more than you use a car. So if you look at the requirement for the plane, and then you looked at what the airplanes were in development, you see a bunch of the urban air mobility, so the eVTOLs. They are around the 5 seats in the vehicle, but they don't really have the range to be able to go that far. Regional air
It's more
mobility.
like flying within a city
Yeah,
rather than
so it's
between
like a
cities.
100-kilometer operational range, maybe, which will get you from Heathrow to London if you could land somewhere, but it's not going to get you from London to Amsterdam or to Paris. They just don't have the range for because they're that inefficient,
Yeah.
effectively, in terms of the energy, the limited energy that they have. Um, but perhaps they are the right size for this on-demand type operations. And then you have got like the larger commercial planes that are 20, 30, 50, 80 seats. And we know from conversations with airlines that they don't really get excited about anything less than 80 seats. Um, so there is this region here where you need to have at least 250 kilometers before you can do anything. But really, McKinsey defined it as up to 800 kilometers. So between 250 and 800 kilometers. And recently, we've seen Beta in the US, who started with an eVTOL, make a move to build an eCTOL, so a conventional takeoff and landing version of their airplane, which is a step in the right direction into this potential market. Um, so that's the plane that we're working on. It will have by 2030 a range of around 1,000 kilometers. That is, absolute maximum range with no passengers, no reserves. But that seems to be kind of the metric that OEMs slap on their product folder. In the reality, it basically means an operational range of 750 kilometers. With the batteries that we have today, we can already do 500 kilometers operationally. So that's that 50% of the private flights that we could
What
already
is
do.
just looking at the aircraft then, what's
Yeah.
sort of some of the features that um kind of key design elements of the aircraft, the design philosophy you're going for there? I can see there's quite long, thin
Well,
straight
I
wing.
will, as I mentioned to you, literally writing the press release at the moment, but there is a new version of what the plane looks like. This perhaps looks like a bit like the Piaggio Avanti, which is the world's most efficient turboprop, which has got the pusher propellers and the canard on the front. It doesn't look like that anymore for a few good reasons. Had to do with certification, but overall is designed to have a very good customer experience in terms of getting in and out of the plane. I'll come back to that in a minute. And absolute maximum aerodynamic efficiency and efficiency overall, so that we get the maximum range out of the limited energy that we have in the batteries. So on the cabin side, you can see there a render of the inside of the cabin looks like. We also have a cargo version of the cabin, and we built several mock-ups to test with our customers what the experience is like getting in and out of the plane for passengers, but also for loading the cargo. So this plane is perfectly suitable for regional air mobility, flying passengers, but also cargo, medical transport, pilot training. So the pipistrelle is a good first start for a single engine plane with a limited amount of range and duration. But when you do commercial airline pilot training, you eventually need to do twin engine work, get your dual engine rating, and you probably will also do your instrument rating in that plane. So you need a plane like this to do it. Today we use, for instance, Diamond DA42 a lot, in example. Um, and then there are some dual use applications that this plane would be suitable for as well, which is, we live in a different world now than we do in 2020 in terms of what's going on in Ukraine. So we need to not, need to not forget that. So as I mentioned, that's kind of a plane that our electric plane, zero emission plane could replace. This is a Diamond DS62, two combustion engines, room for six kind of people, but no luggage then, or four people with luggage. Similar kind of size to what we're building.
And so it's quite different that from those other electric um, aircraft so competitors that are elsewhere on the market you showed in that diagram. So the eVTOL, the vertical takeoff and landing,
Yeah.
relatively complex geometry, lots of propellers, um, high amount of energy to take off and land, and then some of the hybrid electric that were at the larger passengers, longer haul, where it's not fully electric. There's a hybridization with a gas turbine plus electric drive,
Mhm.
and maybe like a series of propellers as well. So, what was kind of your thinking of the conventional rather than the vertical
Yeah, there's
takeoff?
a lot of choices, obviously, design choices that you can make and need to make. So looking at the bigger picture and kind of zooming in, basically, if you look at the eVTOLs, the battery technology isn't quite good enough yet. They are actually more expensive to operate than a combustion engine helicopter. There is no certification pathway, so that means you really don't know how long it's going to take to get it certified. Prime example would be the civil version of the Osprey, so that's the Augustus 609, I think it is, or
Yeah.
W609, and that's 20 years already, that project to get it certified. So yeah, it's a problem. And then the infrastructure, so we have some heliports, but really not everywhere what you would need for these eVTOLs to kind of operate. You need also alternate vertiports. And that's basically like 40% of your operating costs. If you look at the financials that Lilium, for instance, was showing before they went bankrupt. So we think this could be like a decade before it enters the market, and development cost, yeah, it's an unknown number, but in the billions. And then if you look at a car-sized plane, you know, the battery technology is there. It's cheaper to operate than a combustion engine plane. The certification pathway already exists. We have the Pipistrel already flying. All those small airports that we already have, we can use. And actually, a project like this should only really take 4 to 5 years to get it certified if done right. And we can also back test this to similar sized planes that we've done over the years around the world. So we know roughly also what it would cost to get a plane of this size and this complexity certified. And then looking at the big plane again, the battery technology isn't quite there yet, unfortunately. Maybe early 2040s, you can expect a battery electric short haul plane to be viable from a battery technology perspective. It would be cheaper to operate them. Of course, the certification infrastructure is there, but it's still a decently long project, and it will cost you around 10 billion to get a plane of that size certified, which is just a complete non-starter from a startup perspective. So in terms of hybrid, it's funny because in automotive, of course, the first move into sustainability was effectively the Toyota Prius with a hybrid car. Uh, Cars are really inefficient in terms of converting the energy into movement. The motor, you want like 100 horsepower for a short period while you accelerate, and then you're only using like 10 horsepower to maintain that speed. In aviation, we use pretty much full power for the whole climb, and then we run at like 60, 70, 80% of power during cruise, and then we, go down to next to nothing in the descent. It's completely different profile, energy profile, power profile. And so the going for a hybrid system basically means in practicality you end up with a very, very short zero emissions range, you'd probably be flying on hybrid mode most of the time, which would still be better, but you do not get the massive cost benefits of pure electric. So if you can do the mission pure electric, then do it. If the batteries weren't good enough, we would have said, okay, let's do a hybrid first. But actually, it turns out that the battery is good enough for this mission profile, if that makes sense.
Yeah, cool. So I suppose just that's your the product itself. When
Mm.
it comes to actually the aviation business, how these might be operated, what it just explain a little bit more about how you're thinking, that would work.
Yeah, so I mentioned the infrastructure earlier. So if I just show you what I mean, there is roughly 60,000 or so small airports around the world that we can tap into. But today, around 80% of the passengers travels through just 1% of those airports. So that's the busy kind of routes of like London, Amsterdam, Amsterdam, Paris, but also, of course, the long haul flights in Amsterdam, New York, those kind of things. Um, the vast majority of those small airports are underused, and we could tap into those, and they're already being used by private aviation today. Not necessarily, don't necessarily think of like the really expensive private jets with caviar and champagne, but think more of business people traveling from A to B. And those kind of operators are already flying, for instance, the Diamond aircraft that I showed you today and other small combustion engine planes. And so instead of operating the planes ourselves, next to also manufacturing it, which is just a step too much to do, we're just selling the planes to those operators globally. So there's also a logistics company that became a customer and invested in us. But this is all around the world. You know, Flying is already flying the Pipistrel in Australia. And they've acquired an operator with conventional combustion engine planes now, and they want to basically replace those with our planes. Hopscotch is flying combustion engine planes in New York. Air2E is in Germany, and so forth. So that gives you an idea of like this goes into an existing market that most people probably aren't aware of.
Yeah, so and I guess like you were saying, airlines sort of get interested once you get above 80 seats, probably
Mhm.
into multiple hundreds, which will come later. So just I suppose quite keen to get your thoughts on, if politicians did get their act together and we enacted rapid climate action and progressive policies in aviation, what is your vision for like over the next few decades, how air transport might transform, and I suppose also how that flying experience might change for passengers that are flying.
Yeah. So as I mentioned, breaking it down, there is going to be a limited amount of SAF available. It's 4 times more expensive than jet fuel, and we're also going to see more and more emission taxes, which I think is a good thing. We should, you know, punish the emissions, and we should promote low emissions rather than specific solutions. But this will probably make long haul flying more expensive than it is today. And that might curb some of the market growth that we have seen over the last decades. Whereas for short haul flying, particularly at the moment, initially regional flying, we could see a massive growth coming there in the future still, but a sustainable growth going with battery electric. So you'll have SAF for long haul and battery electric for regional and short haul. Um, and then, of course, we have things like autonomy coming into the market as well. It always seems like it's 5 years away, but it's actually already starting to happen now with automotive. And I would say, from my perspective of having been an airline pilot for 15 years, I kind of think it makes sense for small planes up to 19 seats and that they eventually will also go autonomous. You're operating in a protected environment most of the time, so it's actually in some extent easier than automotive to do it. But this won't happen, next year. It's going to be quite some time before the regulators catch up and allow that. And then around 2040 or so, we'll probably start seeing, hopefully, some 80-seaters coming into the market as well. But if I look at Airbus and Boeing and the big incumbents, what they're doing, they aren't really bringing hybrid or pure battery electric aircraft to market. They are focusing on hydrogen, and they have full order books. There's about $750 billion in them at demand. Um, why would they handicap themselves by focusing on building a plane like that? It also brings massive risk. This is going to have to come from a startup, from a new entrant to the market, like we've seen with Tesla. And fingers crossed we can get there. That would be great if at least somebody does that. So I'm also quite supportive of beta as long as they don't focus too much on the eVTOLs.
And for the passenger themselves, is this then your kind of vision would be, I want to get from A to B. I'm currently in Scotland. I want to get to
Yeah.
uh, the Netherlands. Would that be like a case of, well, maybe there'd be an integrated transport system where I'd get um, almost like an Uber or a on-demand public transport that would take me to the locust, but local like regional small airport, and then I'd get maybe a flight to further down in England, and then another flight over to the Netherlands, and then connection again, and less of that kind of airport experience where I go to a large hub. There's long lines. How would that experience change
Yeah.
that door to door?
So maybe not the view of what you're used to, of what an airport looks like today, um, but maybe it could look something like this, where you have many of these small planes coming in and out, like taxis almost. So you get picked up maybe from your home rather than driving your car and paying for parking because the airport's so much closer. So you'll be there in like 15 minutes. I mean, for me, Southampton Airport is 13 minutes away. Then you will jump on that plane and 15 minutes later you're flying. You will fly, up to 800 kilometers according to McKinsey, but the reality is it will be like 500 kilometers initially, and it will go up to 1500 or so over time. Um, and then when you get there, you might then jump into an electric car, either rented or an Uber or whatever it is on the other end, to have a complete door-to-door electric journey, which is extremely low emissions and actually much more flexible than the way that we move today with airlines, the way they operate on very selected routes between the bigger cities with practically no service between the smaller city pairs.
This is quite interesting for us because we sort of, as a group, we know that the current growth of conventional aviation
Mhm.
it appears to be unsustainable. But there could be this growth of almost like an adjacent market for this kind of thing. So how do you think that that will affect aviation workers, and just in terms of like our day jobs or the skills required?
Yeah. So if this regional air mobility, or when this regional air mobility really kicks off, as I mentioned, when prices come down, demand will skyrocket. We're going to need a lot more pilots for that. It's a different kind of lifestyle, like private pilots today. I think also maybe the pilot training cost might come down a bit because electric planes are cheaper to operate, which is a significant part of the pilot training program. And then maybe eventually sometime in the future we'll have autonomy come in, by which point I guess a lot of those pilots might then transition onto the larger planes that will still be flying around. Hopefully there will be also positivity on the sustainability there by that point. But quite crucially, we've recently seen the effect of what's happened in automotive in terms of electrification. Europe hasn't kept up to date, has been like pushing the boat out to say, oh, no combustion cars by 2035. Can we not delay that a bit? Meanwhile, China's taken over completely. And so a lot of the automotives in Europe are now really in trouble. They're having to close plants, cut staff, and actually, there is a huge opportunity here in terms of leveraging those skills in an adjacent industry, which is aerospace. We still have the advantage of you cannot certify a plane in China and sell it in Europe. It needs to be certified in the EASA. So there is actually a huge opportunity for jobs in aerospace in Europe going forward if we don't beat around the bush and we get to it. You know, if we have the same like attitude as we've had in automotive, and I can see it in aerospace happening today, where we're not doing it, then yeah.
So what would you like from governments then, just to get towards the end of my questions? If we are to, let's just say, take action as quickly as possible to secure some of those jobs, to be the pioneers of that in the UK or Europe,
Hmm.
what would you say to politicians they need to, sort of policies they need to focus on?
So I mean, it's easy at the top of the mind for me, obviously, is kind of funding. Being in an aerospace startup in Europe, so this comes around incentivizing people to invest. In the UK, it's actually quite good compared to Europe in some ways, but in other ways, not so much. What I mean with that, you have like tax relief if you invest in a startup where you can get basically 50% straight back from the taxman. We don't have that in the Netherlands or in Europe. That's a very UK thing, which is great. It helps investment in startups. But then you will need access to grants, and that needs to be around more around product innovation and bringing products to market rather than technology development and being in a situation where the majority of the funding just goes to large incumbents and doesn't drive that needed change or that those actual production of those electric planes, for instance, but goes into technology development that might not see the market ever or sometime distant in a distant future when what we need is already there today, and we just need to get on and do it.
Yeah.
And then yeah, think about the carrot and the stick. So we need to really keep on increasing the EU ETS, for instance, so the emission charges to make the emissions that we produce more expensive, so that there is more drive to do something about it. And then maybe we can use some of those funds that are created by that to incentivize the production of or the sale of zero emissions vehicles, like we have in automotive. You have credits there, carbon credits. Something similar can be done with aircraft as well.
Perfect. So final question. What advice do you have for, aviation students or workers at the moment, about getting into this area, if you are kind of hiring at Electron and looking for certain skills or mindset, what sort of thing are you looking for?
So I would say this thing that you can do, the biggest contribution you can make is what you do for work. So, I made a decision at the time to not wait around and see if I can get another job with an airline, but actually be ahead of the curve and work on the solution. This has much more impact, even if you don't need to start your own business, you can go and work at one. Has a much bigger impact than what you drive or what you eat. I'm not saying that we shouldn't look at that as well, but that has a massive impact. And so, what transferable skills do you bring that you can bring into this industry? Or if you haven't got them, where can you get them? Maybe in automotive. If you want to be a pilot, think about doing a pilot training with an organization that's already using the electric planes as part of the syllabus, at least. Yeah, think about it.
Great, thank you. Well, how about we stop recording there?